Okay, so Newton's law of cooling, there is also a law of heating. It's the same thing, we're just going a different direction. You can think of cooling as negative heating, kind of weird concept, but same idea. Okay, so we are going to talk about all the different variables, okay? First of all, the law of cooling, you take something, whatever it is, you put it in a certain, either a room or you put it in the oven, whatever, and what happens is the temperature decreases or heating increases exponentially over time. Okay, so the good news is I'm going to give you the formula. Okay, the bad news is you have to know what all the variables mean. Yes?
When it says over time for the temperature of the starting medium, does that mean that the temperature is being
Yes. Yes. It'll pretty much, it's like keeping your, does anybody keep their butter on their counter?
Yes.
Okay, eventually, you're supposed to, it's real butter, but sometimes it's real like, what? I know she was. I'm trying to mock her now. All right. It's okay. I can talk about it. All right. So the temperature, if you leave your butter out or whatever you leave out, the chocolate that you have in the refrigerator because you like soft chocolate, you don't like hard chocolate, it'll eventually become the temperature of the room. Okay. So that's the general idea of the Newton's law. Okay. So let's figure out what all these temperatures are. It is a little bit related here, but we also have a temperature, like this piece is certainly related to your original exponential decay, but then this is a little bit different. Okay, so a temperature U, so this is a temperature, okay, at a given time. Okay, so if it's U of 5, that means 5 minutes or 5 days or 5 years, whatever you're talking about. Usually not Newton's law, it's not that time frame. Okay, can be modeled by where T is the constant temperature of the surrounding medium. So this is your temperature of, say, your room. Maybe if that's where you were going to put it, or if you're going to put it in the oven, it's your oven temperature. Usually when we're doing cooling, we're taking it out of the oven, putting it in the room, and letting it cool. Okay? Is anybody in here? We got some bakers in here, right? Lana, you're a baker, right? I knew she was. Her family from Germany. Okay. Your family? Your favorite husband?
My family has a bakery.
Oh, where is it?
Queen's Bakery.
That's right. I knew that. I ordered for carrot cake for daughter's house. Not Halloween. Graduation. Okay. All right. Of course, U sub 0. What do you suppose that is? Initial temperature. Okay. So it's like if you're taking it out of the oven, we assume, you know, like the oven's 350, we assume the internal temperature of the cake or the turkey or whatever you're taking is 350, but it's not. But anyway, that's the internal temperature of whatever you take it out. And then there's that T again, which is your temperature in your room. And then E is that natural logarithm E. K is your rate of growth. Okay? And K is going to work out. Don't worry. Oh, remember, it has to be negative. It's all going to work out if you put it in there right. U sub 0 is the initial temperature. And then T, of course, is the same T that matches right here. Okay? So, I'm going to give you the formula. I would encourage you to, when you study it, to know what it all means, because that's the key as any of these. Okay. All right, we've got an object heated to 75 degrees, and then we put it in the room to cool. The air in the room is 30 degrees. This is Celsius, which is 30 degrees Celsius pretty cool? No, it's not. 30 degrees Fahrenheit is pretty cool. Okay, the temperature of this object is 60 degrees after 50 minutes. When will its temperature be 50? Okay. Okay, so for all the problems, for most of all the problems, you are going to find the K. Because if you don't have K, you don't have that to fill in. So tell me what 75 is as far as this temperature, U of T, U of 0, or T. What is it?
U of 0.
It is U of 0, okay? It is the initial temperature, okay? It's heated to that, so that's when you're like, okay, this is what it is. And then what is the 30 degrees? What is that? Lauren, ready?
Oh, wait, sorry. Wait, it's like 150.
Okay. Could you be more specific than that? Yes. T is the temperature of where you're putting this thing to cool. The room, the freezer. Sometimes you put something right in the freezer, then it's supposed to stay moist. And you like that word? Okay. So we're going to take this U of T. If the temperature of the object is 60 degrees after 5 minutes, what is 60 degrees in terms of this equation? U of what particular T? Yeah. How many small t's? 5. There you go. U of 5, of course, that's 5 then. Okay? So you got to start thinking, if you're not yet, you got to start thinking what does that U of 5 mean? That means the temperature after 5 minutes. And when will its temperature be 50? What are we looking for? What is 50? 50 equals what? U of T, where T is what? So, sometimes it's like, what are we looking for? That's what we're looking for. Okay, so here we go. U of T, we're going to find K to begin with. All right, so U of T, I think we'll do U of 5, since we have that to work with, equals T plus, I'll put these in here in minutes, and I'll do the generic here. U of T plus U of 0 minus T e to the K T. And we're going to put in U of 5. Big T, Lauren said was 30, so we're going to put that in there and here. Okay, and Lydia said U of 0 is 75, so we're going to put that there. And Melanie said T was 5, so we're going to put that there. U of 5, she also said was 60. Okay, so while I'm plugging in 60, I might as well get my calculator out, or certainly I could subtract 75 minus 30 without a calculator. What is that? Leah? 45. Okay, I like 5K as opposed to K5. Okay, so go ahead and find your K. Maybe. Everybody have a calculator? Do the algebra, don't. Sometimes this is a nice number, sometimes it isn't. If it's nice, I'll just leave it in fraction form. That's actually it's in fraction, so. Go ahead and store that. And write down okay. I got it. When you're ready, look up. And if I remember correctly, physics Newton's law, it works a little bit differently, but you could probably use it work with the same way. Okay. Anybody not get that to be negative 0.08109, blah, blah, blah. Okay. So I'm going to store that. How do I do that again? So, alpha K. Okay. There we go. All right. Now, give me my equations. Go all the way up. And this is what I did not see a bunch of. I want to know my U of T equals, in this case, my temperature is still 30. My U of 0 is still 75 and 30, so I'm going to go ahead and put 45 here, because there's no point in doing that every single time. And then don't forget I have my K, T. So this is my equation that I'm going to work with this problem, okay? I didn't see you all kind of establishing that yesterday's homework. It's just okay. It's just sometimes a lot to keep track of, and you have that as a reference. You know where to go with it. Okay. So all we've done is find a function. Now we have to go back to do this. 50 equals U of T. So where am I going to put that 50 into this blue equation here? Amanda? Okay. All right, now, I didn't hear anybody adding 30 and 45, right? That's the order of operation problem if you're doing that. So go ahead, find your T. And I'm spelling everything out. So okay, so did y'all get it? Not yet? You can spend some time and simplify your 2045. Go by. Your calculator is going to accept 2045 just as well as going to accept, 4 9s or whatever. Okay? So it's just up to you. All right. Did you get 10? Awesome. Okay. So 10 what? Go back here. In 10 minutes, it's going to be 50 degrees. Okay. Don't forget to put units on your problems because it makes you more conscious of them. And sometimes they switch them on you. They'll say 2 o'clock, and then they'll say at 5 o'clock. We'll then have to figure out. Okay, clearly we're working in hours. That's 3 hours difference. Okay. The second bullet down here. Additional bullet. Determine the elapsed time before the object is 35 degrees. Okay? So we're going to go back to there. That's why it's nice to have it. U of T equals 30 plus 45 e to the k that we found, T for this problem. And the 35 is going to go in here again because that's a temperature. And you're going to find a new T. Oops. What am I doing? What you got, Claire?
Yeah.
Okay. I didn't work it out. We're basically still gonna do, even though nobody says, oh, in 27.095 minutes, oh, for gosh sakes, we're going to keep it to accuracy of 3 decimals, even though we don't talk like that. We are in math class, so yes, 0.95 is supposed to be right. Go ahead, Melanie.
So for practicality problems, like there was some on the homework that said like how many insects we would have at this point.
I would do it statistically still with the 3 decimal point accuracy. It's just like when you hear a statistic, like what's the average amount of people, children that people are having these days? 2.8, exactly. You can't have an 8/10 of a child, but statistically, that's what that means. So, good question. Let's keep it at 3 point, unless it says like, and time is weird too. Money and time, I just like go to what kind of is common, because otherwise it's kind of weird. But you can't go wrong if you do 3 decimal accuracy. Just saying. All right. Did anyone not get this, that we need to do the algebra? Anybody? Alrighty then, let's move on. Okay. So I put the equation up there for you. We're going to fill it in. Object is heated to 100 degrees. That is allowed to cool for 30. Okay. The temperature of the object is 80. After 5 minutes, one will temperature be 50. All right. So what do we know about 100? What is that in this equation? U sub 0. Okay. And what's 30? T, okay. 80 and what? U of, specifically, T, 5 again. And we are looking for U of T, we're looking for T. Excuse me. Okay. Here we go. U of T equals big T plus U sub 0 minus T e to the k T. We're going to find K so we have a complete equation. All right, U of T, I'll probably put, since the only data we have is U of 5, so we're going to put a 5 here. E to the k, T is 30, and U sub 0 is 100. All right. U of 5 is 80. All right, go ahead, find your K. And I'm taking some major shortcuts here, so. See how that, remember at the beginning they told us our K was going to be a negative constant. All right. When you're done, look up and I've got the K sitting here, hopefully. If you're finding yourself making mistakes, taking shortcuts, that's an easy problem to solve. Don't take shortcuts. Okay? Did you get that, Aaliyah?
Yeah.
All right. Good signs, Leah got it. I'm good. All right, right? Store alpha K. All right. Okay, so what's my equation before we get into the second part? U of T. What's my equation, Sarah?
part is, 50 equals.
Well, don't put the 50, put the 50 in later.
Um,
Give me the generic equation that we could do anything with this problem.
UT equals, 100 times
70, okay?
70.
Okay. All right, now put your 50 in and solve. And I don't know that we need to do the second part of this thing. I think we're good. You'll get there already? Okay. What do you got for time here, Kara? Does that sound good?
Sounds great.
I should have long add down. Anyone need to go over all that? We're not gonna do that second bullet because we just did one like that. Let's move on. I think you're good. Okay, do we need to, anybody? Are you feeling uncomfortable here? All right, that's a good question, Melanie. All right, so we're graphing. Graphing. The function. Here we go. Okay, so our calculator. We got to, and that's another reason why most of the problems have you graph it and kind of verify with the graphing. So go to y equals. Figure out what's there. Y is really our u of t, and x is really our t, because that's the only thing this calculator recognizes. So 30 plus 70, oops, not 71. E to the power is the blue ln, remember? To the k, I don't know if alpha k, I don't think I stored this one, so I got to go back and make sure I got my alpha, my k stored. Did I? Oh, I do. Okay. I didn't know if I went that far. Okay. Now, I don't know what I have in here. Stop. Okay. All right. But here's what I like to, when you're graphing, I know my time is not going to start until 0, but I like, and remember my x is my time, okay? So I like to do this just so I can see my, and this so I can see my axes. I just like to see them, okay? Because otherwise it throws me off. So that's why I put -1. All right, now, when you are graphing that function 30, what's the minimum you're going to have at time 0? 70. So you have to, well, no, 70 plus 30 is going to be 100, right? Well, because if I put time 0 in, I'm going to get 70 here plus 30. So I'm trying to figure out my window, okay? My x, what did I talk about? I had 18 minutes come up. I had, I didn't do another one, but let's make sure we accommodate at least that problem, and let's put in 20. Okay? Did anybody do the 35? Because y'all are overachievers. No? Okay. All right. So I'm just going to make sure I accommodate all the answers that are already coming up, because that's what I'm going to check here. Already came up. All right, I got my -1 so I can see my axes. Then it's going to be at least over 100, right? So let's do 110. That's how I manually do it. Now this scale doesn't really matter. Just depends on, okay.
That is an exponential curve. It's curving around. Okay. So let's say this is -1, and we said, what was this, 20? And this was 110. Okay, when it asks for you to graph, when it asks for a graph, grab it. Okay, and you saw that I did that on the thing that I gave you. All right, so now I want you to verify using intersection that when U of t equals 50, t was 18.616. So what would I do additionally on this calculator? How would I do this? I don't have an intersection yet because I don't only. So I go to y equals, and what do I put in there besides that one? 35 or 50. We're doing 50. We could have done the second one. That was a good idea. That would have been a good idea. Okay, graph. You shouldn't have to change the window. 50. There it is. And see, that's why you don't want to go to the end. And then we do an intersection. 5. Enter, enter, enter. There's only one intersection. There it is. 18.616. 50. So there's your verification. Now, if we wanted to do that other one, did anybody not find the intersection? Okay. All right, let's find the intersection. Let's go to here. Let's get rid of 50 and find 35. We may have to adjust our, because I don't think it's going to reach. Let's see, we didn't have that accommodated. So we got to adjust. It's not going to reach yet. So our window needs to be adjusted to 20. What do you think? 30? I wasn't listening clearly. All right, let's try that and see if it intersects at 30. Looked like it had a ways to go. Dang it. All right. Try 45? I'm trying 40. Okay. But see, that's why you have to accommodate the numbers, otherwise you're not going to show up with an intersection. There's your 35. Barely. 45 would have been better when it had Karina. You tried to tell me. And it's what? 39.217. So that was the answer to this. If you wish to do it algebraically later, you need some more practice. What was it? 39.217? What did I say?
Yeah.
Okay. And that is, what's the unit on that? Temperature? No, time. Minutes, right? Sometimes you are looking for a temperature, so you gotta make sure it's degrees Celsius or whatever. Okay? All right, let me pull up the test here and let's talk about the test before I give it back to you, because then you're looking up here and not like, oh, what did I do wrong, instead of that. Make sure I have it. All right, I'm gonna stop that.